Hello and welcome to this new video in our series, A Beginner's Guide to the C Programming Language. In the last video, we discussed loops in C. We covered the while, do while, and for loops. We also discussed the behavior of loop control statements, break and continue. In this video, we will see how to create our first data structure, which is an array. We will see how to declare arrays, initialize, and process the data contained within it. Please like and share this video, follow our channel, and subscribe for notifications on new videos. An array is a collection of data. It's a kind of data structure where you can store data in contiguous memory and can access this sequentially or randomly. So if you want to store a collection of data like student names, weekdays, numbers, etc., you have a choice of creating multiple variables or creating a structure. If you need to perform the same operations on this collection and need to access them sequentially or randomly, you can store them in an array. An array is a named location of contiguous memory that stores a collection of data values. All the elements of the array should be of the same data type. Typically, the elements of an array are processed using a loop. An array can have dimensions. A single dimensional array is a row containing many columns. Each column contains an element of the array. These elements can be accessed using a single index value from 0 to the length of the array minus 1. So in this array, each element of the array can be accessed using a subscript from 0 to 5. As shown here, array of 2 accesses the value of the third element of the array. Then we have two-dimensional arrays, where the array is arranged as an array of rows, where each row has an array of columns. Elements of a two-dimensional array can be accessed using two indexes, a row index followed by a column index. As shown here, table 0, 1 accesses the first row which has the index 0 and the second element in that row which has the column index 1. A three-dimensional array is like a cube. It has three dimensions. The lowest dimension is the number of columns, the next dimension is the number of rows, and the last dimension is the number of two-dimensional arrays present. Again, elements in a three-dimensional array would require three subscripts. The first specifying the two-dimensional array, followed by the row, and then the column of that element of the array. Note that all three types of arrays occupy contiguous memory. It is arranged in the order of columns, followed by rows, and then the next dimension. I will explain this in more detail later on. The size of an array depends on the number of elements in the array multiplied by the size of the data type. For example, the two-dimensional array shown here has 5 rows and 5 columns. So there are 25 elements in the array. If this array is an int array, then the size of the array would be 100 bytes since each element has 4 bytes. Let us now see how we declare, initialize, and process a single-dimensional array. To declare an array, you need to specify the data type of all elements in the array. In C, all elements of an array have the same data type. The declaration of the array consists of a data type name, followed by the array name, and then in square brackets the number of elements in the array. This number cannot be a variable because memory is allocated to the array at compile time. It must be a constant. Another version of declaration of an array is when the initializer list is specified. As can be seen here, the initializer list is a list of constant initializers enclosed within curly braces and separated by commas. If the number of elements in the initializer list is less than the number of elements in the array, then the initial elements of the array are initialized. In this example shown here, the first two elements of the array are initialized with 10 and 20. The third element is initialized to 40. Finally, you need not specify the number of elements in the array if you have a fully populated initializer list. The compiler will count the number of elements in the initializer list and set up the array accordingly. In the third example out here, the array has two elements. To access a single dimensional array, you need to use a single subscript in square brackets. The subscript contains the zero-based index value of the element to be accessed. Note that in C, no bounds checking is done when you access an array. So it is possible to access elements outside the bounds of an array. Now this will cause undefined memory to be accessed, resulting in unexpected results and runtime errors. When you address an element of an array, the addressing mode is called the base index form of addressing. This is because the array name gives you the starting address of the array. The index specifies the offset to the base. As shown here, the address of the element to be accessed is calculated by multiplying the index value with the size of the data type and then adding it to the base address, which is the array name. The element at that address is then accessed. In the example shown here, we have declared an array of 10 elements to store the value of ages inputted via the keyboard. The first for loop inputs 10 values and stores it in the array. Then the second loop proceeds to find the max and min ages of all the inputted values stored within the array. Here we use a macro to calculate the max and min age values. Let's see how this works in practice. In this program, we have initialized an array of student marks in 10 subjects. The program will calculate the average of all the marks and calculate a grade value, where grade is 1 if the average is above 80, grade is 2 if the average is between 60 and 80, grade is 3 if the average is between 50 and 60, and 4 otherwise. Notice the watch window, which shows the array marks. Note that the value column first shows the starting address of the array in hexadecimal, followed by the value of each element of the array. The first loop calculates the total of all the values in the array. We then calculate the average marks and then find the grade. The final value is displayed here. Let's have a look at multidimensional arrays. In practice, an array in C can have as many dimensions as required. What you must know about multidimensional arrays is that a two-dimensional array is a one-dimensional array of one-dimensional arrays. A three-dimensional array is a one-dimensional array of two-dimensional arrays, and so on. Declaring a two-dimensional array is similar to a one-dimensional array. You have the data type of each element of the array, and again, all the elements of an array will have the same data type. This is followed by the number of rows that the two-dimensional array will have, followed by the number of columns each row will have. Note that all the rows have the same number of columns. This is because this is a statically declared array which is allocated memory at compile time. We have also shown here how an array is declared and initialized. Note the initializer list where each row is initialized within curly braces and each row initializer initializes the elements of the row. An element in a two-dimensional array is accessed using two indexes. The first index is the row number and the second index is the element number within that row. So 1, 1 accesses the second row array and the second element in that row. Again, as you know, all indexes start from 0. Another example of accessing elements in a two-dimensional array is shown here. To calculate the address of the elements in the array, the compiler uses the array name to get the starting address of the array name and one subscript to give you the starting address of a row in that array, and finally, array name and two subscripts gives the element of an array. In the example shown here, we have initialized marks of two subjects for 3 students. Then find the highest and lowest marks in each subject. To find the highest and lowest marks for each subject in a two-dimensional array, we use a nested loop. The outer loop iterates for each subject, which is a row in the two-dimensional array, and the inner loop iterates through each subject, which is a column of each row. The inner loop gets the max and min of one subject that is initialized by the outer loop. After the outer loop completes execution, results are displayed. We now display the largest and smallest values from the one-dimensional max marks and min marks array. Let us see how this works in practice. We will work with the same program that we discussed earlier. As shown here, we have declared a two-dimensional array called marks, which is initialized with marks values for two subjects and three students. Look at the watch window. In the value column, it first shows the starting address of the array in hexadecimal. Then in curly braces, it shows the starting address of the 0th row, which is the same as the starting address of the array, and then the values of each element of that row in curly braces. This is followed by the starting address of the next row, and then the values of each element of the second row. Similarly, the max marks array and min marks array also shows the starting address of each array and the value of each element in the array. Since they are not initialized, they contain some junk value. We now single step through the program. The outer loop processes each row of the array, and the inner loop each element of the row. Note that we have started processing the row from the second element onwards, because we have already initialized max marks and min marks with the first element. The loop completes the process for the first row, then control moves to the outer loop once again. Now we will process the second row of the array, using the same process as the first row. When done, we will print the results in the console. The console shows the final values of max marks and min marks for each subject. We have now reached the end of our discussion on single and multi-dimensional arrays in C. In a later video, we will discuss how arrays are passed as an argument to functions in the form of pointers. Please like and share this video, follow our channel, and subscribe for notifications. In our next session, we will see how to create user-defined data types using structures and unions. See you then.